So we stopped at this transportation problem last week. From the textbook examples, I have 3 more problems we're going to formulate. And one of them is pretty simple. We can do it quickly as just like a warm-up. But I see you guys are working on the homework, so you already get some warm-up before the class. Then I think we'll just work on the more complex problems. Make sure we finish these 2 complex problems today. And if we have time, we'll just do the less complex ones. Okay, so I'll give again the problem statement to you. So that's the production and the inventory planning problem. That's a typical problem that industrial engineers will need to solve. And if you can read the problem statement first by yourself, I'll give you a few minutes to read through it. And we'll read them together. We'll read the problem together, and then I'll ask you to do some analysis. Okay, I think you finished reading, so we'll just read them together. So the first few sentences, or like this entire paragraph before the table, again, some general information about the problem, okay? And so their production capacity varies from time to vary from month to month, and their demand for this air compressor also vary from month to month. The cost of unit production too. So that's why they summarize those here. And then, so they have some criteria here now. Given the size of the warehouse, a maximum unit can be held. So this would signal as, okay, we need a constraint here. Okay, so maximum of this 6,000 unit can be held in inventory at the end of every month. Okay, and they also like to keep at least 1,500 units inventory as safety stock, and other keywords for constraints later, to meet the unexpected demand contingencies. To maintain a stable workforce, the company wants to produce no less than 1/2 of its maximum capacity. Okay, no less than, another keyword for constraints. And Yupton's controllers estimate that the cost of carrying a unit inventory in any given month is approximately equal to 1.5% of the unit production cost. Do we have the unit production cost? It's already given here, right? So now we have the we have the unit production cost, and we also have the inventory cost now in the same month. Okay, and Yupton estimates the number of units carried each month in inventory each month by averaging the beginning and ending inventory for each month. So that's how they calculate the inventory cost. There are 2,750 units currently in inventory. That's the beginning inventory of 0 on month 1. Okay, and the company wants to identify the production and inventory plan for next 6 months that will meet expected demand, which is here each month. So they need to meet the expected demand. So that's another kind of a constraint, while minimizing production and inventory cost. So we got our objective function. So that's where our objective function will come from. So the problem is to identify the production and inventory plan. So how many things we're trying to decide in this problem? The production plan for 6 months, right? So the decision is to say, okay, in the next 6 months, how many units should we produce? And at the same time, how many units we should put in inventory in each month. Okay, and our objective is to minimize the production and inventory cost. Okay, so we're going to do some simple analysis here now. Okay, this is the last sentence here. So to minimize the production and inventory cost. So this is not the model yet. Okay, so our objective is to minimize production plus inventory cost. So I'll use C to represent this. We're going to minimize the total cost, which has 2 parts, production and inventory cost. And for each part, we do have the unit cost. So we have the unit production cost. And based on this, and we read earlier, how they calculate the inventory cost is 1.5% of the unit production cost. Okay, so we do have the unit production cost, and we also can calculate the unit inventory cost. And what we need will be how many units to produce. That's one thing we're going to decide, right? We said that's part of our decision. Like, okay, so how many units each month, and how many units each month in inventory. And those will be part of our decision. Those will be probably our decision variables, and they will be used in the objective function. Okay, so with some simple analysis here. Then we earlier said, okay, there are some constraints. For example, maximum units that can be held in inventory at the end of each month. No more than 6,000. Okay, so that's the end inventory, and at least the 1500. So it's kind of like a 1500 less than equal to this inventory here. End of month, okay, less than equal to 6,000 for each month. Okay, for each month. And also they want to meet the expected demand. So the expected demand is here. They also have some maximum production. So that means I'll do the analysis. So here let's say the production in this month 1, I'll put like say P1 would be greater than equal to this unit demanded and less than equal to this maximum production. And that's for every month. Does this make sense, the analysis? Okay, so this is just some very general analysis. So we're going to decide how many units to produce and how many units to put inventory in each month. And our objective is to minimize the total cost, which has two parts. Production cost, we're going to calculate using the production unit cost and our decision variables. And the inventory cost, we'll use those unit production cost multiply 1.5% to calculate each month's inventory cost and multiply the inventory in each month. And there are some constraints here. The inventory at the end of each month need to have some relationship with the minimum one and the maximum, same as the production. Or let's think about it again. So the P need to be less than or equal to the maximum. And the unit demanded here. What do you guys think? Should we say the amount that we produce need to be greater than equal to the demanded, or like think about how are we going to meet the demand? How do we meet the demand? We produce some, right? What else can help us meet the demand?
You take some from your inventory?
Yes, your inventory from the previous month also will help us meet the demand. Okay. So what's the relationship between the, I'll ask you guys are IE, industrial engineers, you know this very well. What's the relationship, help me define, okay, between your demand, this is a demand, okay, your inventory, and the production unit. So what's the relationship among them? Can someone Cody?
Isn't it like
A graph or a mass function?
Yeah.
Or describe it. Can you say that?
What?
What's the relationship if you write it as a mass function, or anyone else?
I don't remember exactly what it is.
Okay, so what's the relationship? Say, okay, let's see, demand in month 1, okay? And for inventory, is this clear enough? Or what else do you need to know if I just say inventory? Probably you need to know, is that the beginning inventory or the ending inventory or the average inventory, right? Okay, so let's see, inventory 0, this means the end inventory of month 0 or the beginning inventory of month 1, okay? And if I put another one here, inventory 1. So what use symbols? D represents demand. D1. I0 means the ending inventory. So those are the ending, okay?
Would it just be demand minus the inventory equals the production?
Close.
Could we do demand equals some variable inventory plus some variable tax?
Plus what?
I was thinking demand equals
Demand equals to, okay.
some variable inventory 0, like a percentage of, or maybe a number of units from the inventory.
Okay, so here I'm using I0 to represent any ending inventory of 0 months or the beginning inventory of month 1. This is the ending inventory of month 1. And this is the unit produced in month 1. Okay, so can you use these 4 to write the relationship between them, among them? You produce to meet the demand, right? And you can use the previously left inventories plus what you produce this month to meet demand. And at the same time, you probably leave some in the inventory again. Can everyone think about it and write a formula? And share with me? D1 means the demand in first month. I0 means your beginning inventory in first month. I1 means your ending inventory in your first month. And the P1 representing the units you produce in first month. You can write a closed form function using those 4 symbols and what it is.
Could it be like B1 equals I1 minus I0 plus P1?
I1 minus I0 plus P1. Okay, so what's the logic? Demand equals to be the ending inventory subtract the beginning inventory plus production. Okay, close. Need to switch the sign.
Do you use the average production, Dr. Chen? for
You
that?
can. Well, average
Minimum.
production, how do they calculate the average production? But probably not in this case, okay? If you use average production, it's like this, right? This is how they calculate the inventory, the average inventory. But here, focus on my question. How do you use these 4 to write a closed form function to represent the relationship? So think about it. At the beginning of month, you have some inventory left, okay? So that's I0 here. You have some units left. And then you produce some. So you add to the total pool of the number you have. You produce some, that's the P1. And then you meet the demand, that means you use those ones from the pool, right? So you meet the demand, that's the D1. And what's the left part? The ending inventory of that month. So can you write it now? At the, oh. Okay, so at the beginning of the month, you have some leftovers from previous months, okay? And then you produce more in that month. And from here, you use this many to meet the customer demand. And what's left is your ending inventory. Take a look, see if it makes sense now. Okay. Remember this relationship. A lot of people forget about this relationship in the homework. Like that will make it really messy. How do you link all those variables together? Okay. So that's the relationship. Okay. So now we say, okay, we're going to meet those demand, and those demand are really those values here. Okay. And what we don't know is how many we're going to produce and how many we're going to put in the inventory every month. So now if we don't know this part, if both of those are variables, we actually know this I0 here. There are currently 2,750 units in the inventory. So this is the I0, okay? 2750 here, plus P1 minus D1 is 1,000 equals to your I1 here, okay? And we can do the same for the rest of the month. The only exception is that for the second month, this part, we don't know the actual value now, because we know what's the beginning inventory. Then in the second month, because the problem is not solved, the P1 we don't know what's it. That's why then we don't know what I1 is. Okay, all we have is this relationship, so we can just put I1 plus P1 here. Oh, sorry, P2. Well, in the second month. Okay, subtract. The demand there is 4500. That gives us I2. Then I2. So we're in months. Those are months. 1, 2, 3. So we're in month 3 now. ending inventory from the second month, which is now the beginning inventory of third month, plus your production, subtract the demand 6,000 equals to I3. Then I3 plus P4 subtract 5500 is I4. And go to the fifth month. I4 plus P5 subtract the demand 3500 equals to be I5. And the last month, I5 plus P6 subtract demand 4,000 I6. Okay, so that's one relationship that we can define, and that's how we use those values here. So the maximum production, we could say, okay, it's basically just the units that you're going to produce in that specific month need to be less than or equal to these ones. But how do you use this demand? This demand, you will need to use it to establish the relationship between your P's and the I's. Okay, and earlier we had a question about should we use the average inventory. Can I ask why you asked that question? Why do you want to use the average inventory? That's a good question.
Yeah, I mean, I was just looking at how to put together that equation, and I'd read up above that they would use that average inventory number to calculate, so that's
Yes.
maybe we should try to.
That's a good thing. Okay, so I think that came from here.
Yeah.
They estimate the number of units carried in inventory each month by averaging the beginning and end inventory. Okay, so by averaging beginning and inventory entry for that month. Okay, so that's how they're going to calculate the averaging cost, the inventory cost. The inventory cost. Okay. It makes sense, right? It doesn't make sense to use like the unit inventory cost multiply, say, the beginning inventory or the ending inventory. It makes sense to use the average inventory to calculate the inventory cost in that specific month. Okay, so that means here, we're going to use, for example, the first month would be 240 times here. So I'm reading from here, okay? This 240 times this 1.5%. 1.5% times the average inventory. Okay, so that's what you're going to use in your objective function. The production part is pretty simple, right? The production part, you just use your P1, P2, P3, multiply those production costs and add up together. Okay, but the inventory part, what they calculate is they need to use the average inventory, multiply those unit costs. So one difficulty in this problem is that when students try to define the decision variables, it's hard to think, well, should I, for the inventory part, P is pretty simple. For the inventory part, should I use the average inventory as a decision variable? Or should I use the beginning inventory or end inventory? So if we use, think about it, if you use average inventory as a decision variable, how do you represent those parts? Like how do you represent the relationship between your inventory and the production and the demand? Is there a way to do that? If my I here, if my I here is average, okay. So for example, if I put I1, I'll use different color here to differentiate. If I use I1, and this represents the average inventory in month 1. Okay, it will make it easier for me to write my objective function. So I'm going to just put minimize, so the production cost, okay? Production cost, I'm going to simplify here now. Plus 1.5% times 240 times I1 plus 250. 1.5% times 250 times I2 all the way to here 260. 1.5%. 1.5% times 260 times I6. Okay, so if I define my decision variables as the average inventory in each month, it will make writing the objective function pretty easy here. But what about the constraints here? When I try to establish the relationship, say how should we use the demand? Is there a way to do that? Use I1, I2, I3, all the way to I6, defined as average inventory. What's the relationship between P1, D1, and I1 here? I only have these three now. Is it possible? If all I have is the average inventory as decision variables. Is it possible to write the relationship here? Yes or no?
No.
No. Okay. If you only have the average inventory, there's no way to write the relationship. Okay. So one difficulty here is if we started from the objective function to think, because we know what we need. Okay. The decision variables are production unit and inventory unit. Then for the inventory units, if we start from the objective function here, we will think, okay, because the objective function needs average inventory, let's just define it as the average inventory. Then you will find later it's impossible to write your constraints because using your average inventory, you can't establish it, the relationship with your demand and the production. Okay, but if you did do this, it's not the end of the world. You can write another constraint to say, okay, if that's my ending, like average inventory, then I'll have to specify, okay, I1 equals to be, let's see, maybe we'll use different, yeah, okay, so we can do like a B1 plus E1 divided by 2. So here say, okay, B1 representing the beginning inventory in month 1 and E1 representing the ending inventory in month 1. And here, then, here, you change those as E1, E0. You change this one. Okay, but not to confuse you, we'll just go from the beginning. We're going to use I to represent the inventories. Okay, so.
Hey, Dr. Chen,
yes.
Could you write those in terms of an average? So like in the
like these ones?
In the months, you know, we have 2750 plus P1 minus 1000 equals I1. Could you write that 2750 plus P1 equals, I'm thinking I average would be like, I average would equal I1 plus 1000 divided by 2. You know, try to, so that you're using an I average in both parts of those equations rather than using.
So you are thinking because the I represents the average, so you divide it by 2. So, or maybe like multiply, probably you are thinking about multiply by 2.
Yeah.
So that's the total. That will have a problem because the beginning inventory and end inventory, they are not the same. You always start with the different beginning inventory and the different end inventory. If the beginning inventory and end inventory are the same, for example, you start with 1000 at the beginning, 1000 at the end, then your average inventory is 1000 plus 1000 divided by 2. It's the same. Okay. But if you start with 500 and ending with 1500, your average is 1000. It's not either 500 or 1500. Okay, so that will have a problem. So for this problem, the only way to do this constraint is to define your inventory as a beginning inventory or ending inventory. Okay, so that's what we're going to do. We're going to start now. Okay, so we are writing the model now. Our decision variables. Our decision variables, we need two groups. PI represents unit to produce in month I. Okay, and then I represents I'm going to use ending inventory. Okay, ending inventory in month I. So here I goes from 1 to ... 6. But for inventory, I'm going to start from 0 because I need the beginning inventory of my month 1, which is the ending inventory of month 0. Okay, and then the objective function. We want to minimize the total cost, so we'll do the production part first. 240 P1 plus 250 P2 plus 265 P3 plus 285 P4 plus 280 P5 plus 260 P6. So that's the production part. And we said the inventory cost, the unit inventory cost is 1.5% of the unit cost. So I don't want to multiply the 1.5% every place. I'll just put it outside of the bracket. So 1.5 multiply 240 times. So because we said the inventory cost is calculated by using the average inventory. And because we define inventory as the ending inventory, so here we need to do I0 plus I1. Okay. So one mistake people usually make here will be just to put like I1 here. But by like the definition from the problem, it says the inventory cost is calculated by using the average inventory. Okay. And 250 I1 plus I2 plus 265 I2 plus I3 285 I3 plus I4 plus 280 I4 plus I5 plus 260 I5 plus I6. Okay, so that's our objective function. This part is production cost, and this part is inventory cost. So that's the two parts of our objective function. Then we'll put the constraints. So if we go back to the problem, we identified some of those constraints already. We said, okay, like those keywords, the maximum, at least, no less than. Okay, So a maximum of 6,000 can be held in inventory at the end. Good. So we're using the ending inventory now. Okay, so all the ending inventory. And also they want to keep at least 1,500 as safety stock. So that means for all the inventory, so 1,500 less than equal to I less than equal to 6,000. And this is a 4. This is a 4 all i's. That goes from 1 to 6. So that means we have 6 constraints there. So like in your Excel, that means there were 6 of them. Actually 12 of them. Both sides. Okay. So that's the inventory. Then we take care of these ones. So done. And the company wants to produce no less than 1/2 of its maximum production capacity each month. Okay, they also have a production capacity. So we're going to take care of those ones. That's basically the lower bound and the upper bound for your PIs. Okay, so that's the next group. So, and because their lower bound, upper bound are different, so we can use just a generalized constraint like this to write. So we have to write them out. So the minimum is 2,000 for the first one, P1. Maximum is 4,000. Okay, so that comes from your table. Okay. Then half of 3,500 less than equal to P2. Let's go 3,500. Again, 4,000. Oh. P3 less than equal to 4,000. 4,500 less than equal to P4. Like in the exams or like homework, it's probably better just to put those. I'm not saying like you will make calculations wrong, okay? But just simply put those. You don't have to calculate those actual values. So like in case you had a typo there or something, I know you know the way to calculate them, to formulate the model. Okay, and then 5,600. 4,000 less than equal to P5 less than equal to 4,000. Less than equal to P6 3,500. Okay, so those are those obvious constraints where they said, okay, we have those capacities no more than at least the maximum, so we take care of these ones, and we also used these ones. Unit production cost, we use them. Okay, so the only thing we didn't use is the unit demanded, and that's not kind of like a constraint, but it's kind of a linking constraint that help us establish the relationship between our two variables, the p's and the 1's. Okay, so you will need to add the group that we just put here. Did you guys write down this group already? Okay, so this one, this entire group is also a constraint. Okay, see if I can copy it. Yep. Copy. Oh, copy the entire thing. Okay. Probably not the, okay. So all I want is just this part. Okay. So besides this one group, This is group 1. Group 1 constraint. Group 2 constraint. Group 1 is actually here. You need the third group, okay? Which is this. So this is the third group of constraints to solve this entire problem. And now let me ask you, with all of these, what do you think? Are these both decision variables? Or when you go to solve that in Solver, like in Excel spreadsheet, which ones you are going to shade in yellow? Are you going to shade both of them? A decision variable means that the ones that the solver will have to determine the value, and its value determines your other part, like what your objective function will be, what your left hand side of constraint will be. So are these both decision variables? Especially thinking about here. So if the solver determined a value for P1, can it still assign a random value to here? Probably not, right? So that means among these two decision variables, only one of them is the true decision variable. The other one is just a variable that's kind of like a supporting. Okay, so for example, when we implement in Solver, this will be the decision variable that Solver will determine a optimal value for those PIs to assume, so that when the problem is solved, I will get its value and your objective function will be optimized and all the constraints will be satisfied. Okay, and that's because once a p-value is determined based on the constraint here, I1 will be determined. And once I1 is determined, you have a value here. Solver mainly need to determine what's the P2 value here. And the P2 value is determined, then you get the I2 value, so it will be solved in the sequence. Yes?
Could you just write that whole box like simpler, like I that n minus 1 plus pn minus dn equals in or whatever, like I.
The problem is like those values change.
Yep.
So if you have like exactly the same value, you can basically write I minus 1
Yep.
plus pi minus. So
That's what I'm saying. Minus di
equals to b. And then you will have to specify what the di values are, because when you write in this way, people will think this is a variable too. Okay, so you will have to say like a where. Okay,
define it somewhere else.
so you can say where d1 is 1000,
Okay.
d2 is 4500, d3 is 6000. Okay, that's one way to do that. And also, we're not done yet. Oh, well, yeah. Once you define all of those, okay, like all the way to d6 is 4000. Another thing you need to define is also I0, because that's a given, right? If you don't have this value here, then it won't solve. This will be a variable. So if you do want to define in this way as a constraint, then you will say, okay, this represents one group of constraint where those are the given value in that constraint. Okay, so that will be the accurate way to define it. If you only have this part without defining the di value, then that will be wrong. Okay, yeah, good question. Yeah, that's sometimes I try to introduce this like so you can save some time when you do your problems. But I found many times students miss a part also and make it wrong. So I said, well, if you are really not sure how to write them in the abbreviated way, then just write them out so you don't lose points. Okay, so this is the problem. Then, do we need the non-negativity constraints? How many say yes? No? Okay, good. Why?
Because we already have values that they can't go below.
Okay, they already have their lower bounds, right? So there's no way they can go below 0. Okay, good. So let's take an early break. 5 minutes? Okay. We'll come back for the next one.
Standpoint on the, this is, I am sorry.
Thursday.
Okay. Are you ready for another hard one?
No.
Yeah.
No? In 2 minutes you will be ready?
That one was too easy.
For that?
That one was too easy.
Yeah, it's only the third week. You're getting always better. Okay.
I don't like it. I don't like it. I knocked out. It's like my girlfriend's mom was a baker. And she was like part of the ridiculous like doing and like in our class and she uses it. So the worst we can go work in finance. It's a funny thing, something I said during this like when I graduate, like working in service industry or something.
Okay, everyone got a copy? Okay. So you remember, like last week when we talked about that investment problem, Tanner asked the question, where do we use those maturity years, right? Like in that problem, the issue bonds, they mature like a different period. Okay, like some are mature like 7 years, some 11 years, some 8 years, and at that time we said let's just ignore like the reinvestment. Okay, in that specific problem, we only think about whether it's long term or short term using those years. And in this problem, we're going to think about the reinvest. When an investment is available, we're going to consider reinvest in that option. Okay, so I'll ask you read the problem first, and we'll talk about it. So give you 2 minutes to 3 minutes to read through the problem. Think about what are they trying to decide. Okay, if you finish reading, think about what are they trying to decide. There's no obvious word or sentence there telling us like what's the objective. First, we need to figure out what are they trying to do. So they want to decide, they want to build this new location. And they want to establish a construction fund to pay for this facility, which requires 3 payments, right? That the total is 800. So this construction fund is going to pay for this 800,000 at the 3 times, 250,000 at the end of 2nd and the 4th month, and 300,000 when the restaurant is complete. And to pay for those payments at different times, 3 different times, okay, they can invest in those different options, and they mature differently. And they explain this table here, say, okay, investment A will be mature every month. Okay, so that means at the beginning of month 1, you can invest in A. Then at the end of that month, or which is the same as the beginning month of month 2, you can get out the principal plus the interest and reinvest in A again. Same with at the end of month 2, you can reinvest in A, get the principal and interest from the previous month, reinvest. So you can reinvest every month. B is a little different. It matures every 2 months. So you can invest at the beginning of month 1. After 2 months, when you get to the beginning of month 3, it will mature, and also at the same time become available. Okay, so you can get, if you invested in B at the beginning of month 1, then at the end of month 3, you can get your investment out. So the principal plus interest, you can get them out. And if you decide to reinvest in B again, then you can invest in beginning of 3rd month, same as in month 5. Then for investment C, it matures every 3 months. So if you do invest in the 1st month, then you can get out at the end of the 3rd month, which is the beginning of 4th month. Okay, and if you decide to reinvest again, then you can reinvest in it at the beginning of 4th month and get it out like at the end of your 6th month. Okay, then D, it matures, it takes 6 months to mature. Okay, and the purpose is to make some investment, make some money out of them, so that the money you get at the end of your 2nd month and the 4th month, you can pay for those $250,000 here, and maybe do some reinvestment, and eventually you have to pay this $300,000. Okay, so what is this company trying to do? Or what's the decision? Like, we can use a very general sentence. Okay, they want to determine the investment plan. Okay, and if we want to translate that to, say, decision variables or variables, what are they? You? Okay. The one behind you? What's your name? Sam. Any thought? So what are they trying to do? Or what's that?
Just meet the requirements for the fund, but so least amount.
Meet the requirement of what? Not the fund.
The payments.
The payments. Okay, then they want to meet the requirement of the payments. There are 3 payments. And you said they want to spend the money. Okay, how do they spend the money? They need to make the payment. So what's the other thing? For example, at the end of 2nd month, they need to pay $250,000. What's the other way of spending their money? Think about end of 2nd month, okay? At the end of 2nd month, they do need to pay $250,000. What else? to reinvest. Okay, to reinvest, maybe like A at the time is available, right? Okay, and later, for example, if we think about month 3, then they need to reinvest in B. And then why do they need to reinvest? To get more money to do what? To make the further payment, right? They want to get more money to do the second $250,000. Okay, and so at the end of the 4th month, they need some money to pay the $250,000, and maybe reinvest. To do what? To make more money to pay the last payments, okay? To pay the last payment, which is $300,000. Okay, so that's what they're trying to do. Then what's their objective? The objective is not really trying to meet the payment requirement. That's kind of a constraint, right? That's like, well, we have to meet those. Then what's the objective?
Minimize the sinking fund.
Minimize the sinking fund. Okay, so where is the sinking fund? Or when do you use it?
That's what you pull the money out of to pay for.
Okay. So what they are trying to do is they want to take some money today, right? Put them in those investments so that they can roll and then pay those payments. So that's the money they take out of pocket today is that sinking fund. And they want to minimize what they take out of pocket today. Does that make sense now?
There's no actual constraint on what they're taking out of their pocket.
Right, because they didn't set anything. So okay, we only have like $1 million. This is how much we can invest. But so that becomes our objective. Okay, like in the previous investment problem, they have we have the $750,000 we want to invest, and our objective is to maximize the total return. But in this problem, the objective is really say, okay, we want to decide how much money that we want to take out of pocket today, and how much money we reinvest every month when those investment options are available. And our objective is to minimize the out-of-pocket money today. Okay, so our decision variables. First would be if we use A to represent. Oh, before I tell you, how many decision variables will we need? Or how many parts? We said there are 2 parts of this problem, right? The first part is how much money we take out today. Okay, so just consider now it's like month 1, okay? Or like the ending month, so we'll use like representing end of month 2. So we have A0, B0, 0, and D0. Because we know that the investments are available at the beginning of month 1 or like ending month 0, okay? And we can invest in A, B, C, D. So those are some decision variables. What else? Those are how much to put in today, okay? Now, 1 month passed. It's kind of, they have to make a decision every month. 1 month passed. What are they trying to decide now? Now we are at the beginning of month 2, okay?
How much to reinvest?
To invest in which one? Okay, so at the beginning of month 2, the only option is to invest in A, okay? So now, we're like we fast forward to 1 month to the beginning of month 2. Then we can decide, or should let me do this. I'll use like ending one to make it less confusing. So sorry, it's easier to wipe here maybe. Okay, A, B, C, D. So I'll use the subscript. We'll change it to ending. Actually, these are like a beginning. So these represent amount of money to invest in A, B, C, D at the end of month I. Okay. So AI, BI, CI, DI. So that's the general definition, okay? But we're going to, this is a general definition. The amount of money to invest in A, B, C, D at the end of month I. It's always messy when we consider like there's a month, there's a beginning, ending. So when you define your problems, make sure you make it clear. You are talking about the beginning or the ending, okay? Make it clear from the beginning so that when you write your constraints, you know, okay, I'm talking about the beginning of the month, or it's like the ending of the month, or it's the average of the month.
Maybe we change it to A1, B1, so we can do it at the beginning of the month? Or is it still not?
I'm so sorry, why? At the beginning. Typo. Beginning. Thank you, thank you. Sometimes when I'm talking, I just write the wrong thing. Okay, so that's at the beginning, because we usually make investment at the beginning of the month, right? Make more sense. Okay. So now at the month 2, we said A2 is the only option. Okay, so we'll do A2. Then what about the third month? If we're at the beginning of the third month, which ones can we invest?
The beginning of the third?
Yeah, beginning of the third month. So where do we look? We look at here, like available in months. Okay, so we can do A3. And what about B? We can do B3 too. B3, okay? And then fourth month, we can do A again. A4, can we do B? B is not available, okay? Then we can do C, C4. Then 5, month 5, we can do A again. A5, B, we can do it. B5, and nothing else. Okay, and what about month D, month 6? Should we invest in month 6? Why? Good job, good job. Thank you. So you make the payment at the end of the 6th month. So that means at the beginning of 6 months, we can still invest in A, okay? Well, why not make some more money if it's available, right? Okay, so A6, we can do A6. Okay, then that's all our investment that we can do. So those are the decision variables. And to write the objective function and the constraints, let's do some analysis. Okay, we said we're going to, the purpose is to meet the payment requirement and do the reinvestment. Okay, and so we're going to do so this is a month. 1, 2, 3, 4, 5, 6, and let's do inflows. Say cash inflows, and here we'll do cash outflows. I'm going to make a table. With this analysis, the constraints and the objective function will be much clearer. Okay, so we have the cash inflows here. Okay, so the I'll wait for you. So this table is not in the slide, so it will be helpful if you put like all the other constraint, everything in the slide. This is the analysis part. So for every month, we're going to look at what are cash inflows and cash outflows. So the cash inflows come from when you invest in investment option and you take the principal and the interest out. Okay, so that will get cash inflows. And cash outflows represent when you make a payment, make an investment, and also you make a payment. So this is something extra. So we look at the first month. We're talking about the beginning. Okay, beginning. At the beginning of the first month, that means we need to go to 7. At the beginning of month 1, we don't have any cash inflows. It's like represent the current point. We'll just take out some money. So we don't know whether we're going to invest or not, but we'll just put them here, say, and the software will decide for us. So the beginning of the first month, we're going to decide how much money, if we should at all, to invest in A, B, C, D. And those are our decision variables. We don't need to make any payment in that month. Okay, and we don't have any cash inflows within this context of this problem. Okay, and then in the second month, starting from the second month, do we get any cash inflows? Okay, anyone from the back? Any cash inflows from the beginning of at the beginning of second month?
From A.
Who said that?
Yeah.
Okay. Yes?
From A.
From A. Okay, so how much?
How much we invested times the yield and maturity.
The maturity, or we also get the principals out, right? Okay. So that would be,
A1.
so that's 1.5, that's the yield, okay? And then we also get the principals out. So it's a 1.5%, okay? Times A1, okay?
That's the beginning of month 2.
Right, the wrong place. Thank you. Yes, it's 1.8% times A1. Okay. We don't get any other ones, right? That's the first month. So beginning of second month. What about cash outflows?
A2.
A2, yeah, that's the only available ones, right? We have A1, A2, nothing matures available at month 2. Okay, then we'll continue. Beginning of month 3, again we get from A, right? 101.8%. A2. Anything else? Hmm? B1 is mature now. Okay, so B1 is B's rate is 3.5. Okay, so 103.5% times B1, right? It's from the first month. Then what about cash outflows? Beginning of the third month, we can invest in A and B, not a C or D. So basically, the one that matures, then you can get reinvestment. Okay, so you can do A3 and B3. Anything else? The cash outflow in that month. That's the beginning of the third month. It's also the end of the second month. Any clue? Anything missing? Remember what's the purpose of establishing the fund? To make the payment, right? And they want to make the first payment at the end of the second month. Okay, So we do have a payment at the end of second month, which is the beginning of the third month. So here, 250,000. Okay, now then we go to the beginning of fourth month. Again, A will mature. We know that every month it will. Then let's look at which one is available in 4. So, okay, so C will mature at the same time, right? So is that right? Matures in 4th month and 5.8%. So 105.8% times C1. Okay. So remember the subscript here is from the previous investment, so it's C1 here. Don't put C4. Then you can invest in A4 and C4. Not anything else. Then no payment that specific month. Then 101.8% A4. And I think B is going to mature again. B matures every 2 months, right? Yeah, so that's a 5. So that's 103.5% B what? B3. Okay, thank you. Anything else? That's a 5. C is not done. The second C is not done yet. D is not done yet. Okay, so then A5, B5. And this is the beginning of month 4. Beginning of month 5, which is the ending month of 4. So if we put like ending, here it's kind of like a 4, 3, 2, 1, 0, 5, 6. Okay, so this part is like the ending. This part is beginning. Ending of the 4th month, we need another payment, 250,000. Then we continue 10.8%. A5. Probably C matures again, right? 105.8%. Because C matures every, you do C1. C matures like 4 months. Oh, probably not. So 1, 2, 3, 4. So not the C here. Every 4 months. It's only A. So then you can do A6. Question? Is this right? Beginning of month 6. Yeah, okay.
Does D1 not? D1 doesn't mature then?
Then D1 would
Returns.
come here. Right.
Yeah.
Yeah, like if we look at like ending, then it takes 6 months. So 101.8% A6. And the B will mature again, 103.5. Everyone matures this month. 105. Oh, needed more space. Okay. 103.5% B5 plus 105.8% C4 plus, what's D's rate? 11%. It's D1 here, okay? So, any more investment? No meaning now, right? The only thing we need is this. Okay. So this is kind of like the balance sheet analyzing the relationship. So now let me ask you, which part is our objective? We said we want to minimize the total out-of-pocket money today. is it minimize A1 plus B1 plus C1 plus D1 plus A2 plus A3 plus B3 plus A4 plus C4 all the way plus A6. Is this right? How many say yes, right? Okay. How many say no, not right? You raise your hand twice, right? Okay, yes.
Minimize your investment if like you're trying to spend the least money out of pocket.
Uh-huh,
You
uh-huh.
Minimizing your investments when you can like make a lot more money by investing more.
Okay. So think about where does, let's just think about this one. Where does A2's money come from?
Well, it comes out of your pocket.
From A1, right?
Yeah.
From A1 plus some of the interest. Okay, what about A3?
It's going from
A3's money comes from A2, which comes from A1 and B1. Okay, so which part is the real out-of-pocket money? Which part is really
A1.
A1? Okay. What about B1? A1, B1, C1, D1. Those are the real part that's out of pocket, right? The other part is really they come from the previous investment, which come from the previous investment from the previous one. Okay, so if we put the objective function this way, we like count those like A1 several times. Okay, but the real out of pocket money is only the one that we invest in the first month. Okay, so our objective function is actually this one. Okay. So that's one mistake we may make. It's like count all those decision variables together because they all represent investment. But really need to think about where do those money come from. It's all coming from the first month. Does that make sense now?
Yeah.
Okay. So that's our objective function. Then constraints. What are the constraints? Constraints are already in your table, right? So besides, let's see, except this part, except this part. This part we said it's objective function. We add those together, we want to, minimize. We want to minimize this part. Then starting from the second month, okay? This is how much you can get. Can you invest more than what you get? You cannot, right? So this A2 money comes from here. So A2, the amount of money you put in A2 need to be less than equal to what you get at that time. Because at that time, you are no longer going to take money out of your pocket. If so, we'll need to add more decision variables and make the problem more complex. Okay, but at this point we're saying, okay, the A2 money can only come from here. If we are going to invest in A2 at all, that money should be from here. Okay, and then the same in the beginning of your third month, those are your cash inflows. Okay, and you need to meet the need, which is make more investment plus make that a payment. Okay, so like this part need to be less than equal to these two together. So these are the money that you can have at the beginning of month 3. That's the maximum that you can do to make this payment and make reinvestment. So that goes on for all the months. Okay, so for each month, the money that will come out from your previous investment together need to be enough for you to make more reinvestment. And in some cases, should be enough to make more investment plus make that payment here. And this last one, greater than or equal to 330. So again, we use a greater equal sign here. Some of us may think, well, what about let's just use equal sign. The risk of using equal sign for each of them is that we may not be able to find a solution that make them strictly equal. Okay, sometimes, for example, here, you probably need to save some money from here. See if it makes sense to you. If we you may want to save some money from here, not invest all of them, so that later, or probably not for this problem. Think about this. Can we use equal sign? If we use equal sign, that means we're going to invest all the money to, for example, here. We're going to invest all of those to A2. But if we don't invest all of them, if we save some money, where will that money go? That money will just go somewhere. It's not going to fit into the later part. Okay, so in this problem, in the optimal solution, if they can find the optimal solution that satisfy all the equal sign constraint, then the optimal solution will be just equal. Because if they save some money from here, there's no use. It just they're not going to use that money to do reinvestment. Okay. However, we're still going to use greater than equal sign because in some cases we'll just make it less restrictive to make sure it can find a solution that satisfy all the constraints. I'll talk about this like when we illustrate. If we just use a strict equal signs, some of those constraints may not find a solution. Okay, it's hard to find an investment way that make the left hand side strictly equal to the right hand side. There may be some like you need to leave some buffers there in your constraints so that the solver can find a solution. Okay, so for this problem, I'll just show you the and we'll just need the non-negativity constraints. So all the i's, all the AI, BI, CI, and D1, they all need to be greater than 0 for all I. That goes from 1, 2, all the way to 6. So that's the problem. And I'll show you the model here. So minimize the total out-of-pocket money today. And these are the constraints plus the non-negativity constraint, like what we said. So equal sign is okay, but we prefer greater than equal to signs in all those problems to make it less restrictive. Okay, then now we're not going to talk about implement the model until probably next Thursday. If we can finish all the others, we'll do it this Thursday. Okay, so we have 15 more minutes. We'll add one more condition to this problem. Okay, make it more challenging. So assume this company is the CFO assigned the following risk ratings to each of these investments. Okay, for investment A, B, C, D, they have a risk. What it means is that for every $1 that they invest in A, they will have that $1 will have 1 unit of risk. Okay, and the higher the value is, the higher the risk is. So investment C seems to be like the most risky. Okay, and if you look at the yield is okay. It's hard to tell because they mature different months. So C is like 5.8%. So there's no like strict relationship. But they add this risk rating there. They said, okay, the CFO does not want the weighted average risk to exceed 5. Okay, so we have the previous model. Now we are saying, because every $1 that you invest in A will give you 1 unit of risk. Okay, and every $1 you invest in C will give you 1 unit, will give you 8 units of risk. And the CFO wants the weighted average risk to not exceed 5. How to calculate the weighted average risk? So suppose we'll just use ABCD to represent the amount of money you put, okay? So every 1 unit of, I'm going to use values to illustrate. So suppose these are our investment, 2, 4, 6, 7. So we're going to invest $2, $4, $6, and $7 in each of those. And we said each dollar in A will bring 1 unit of risk. So what's the average risk? Would it be $2, right, of A times its risk plus the $4 of B. So B in total brings 12 units of risk. Okay. I'll still leave this sign here. Plus $6 of C. Actually, if I put the units there, I'll need every. So this is like a unit risk per dollar. Those are risk per dollar. Okay, so for every $2 in A, it will bring 1 unit of risk per dollar. Plus $4 in B, it will bring 3 risk. And $6 in C will bring 8 units risk. And plus $7. Can you see it? Oh. Next time let me know, okay? You can't really read, right? Can you? It's okay? Okay. Okay. Try not to. So I'm going to change this. So $6 per $6, 6 units per dollar. So these are the total unit of risks when we bring into the total portfolio when we invest 2, 4, 6, 7. Okay, and in total we have $2, $4, $6, and $7. So this gives us the weighted average risk of this entire portfolio. Okay, is this part clear? The weighted average risk. Okay, simple math, right? Okay, then how do we write constraints that restrict the average risk, weighted average risk in every month to not exceed 5? Then we need to look at every month, right? If we go back to every month here. In the first month, how much do we put in? In the first month, we have A1, B1, C1, D1 in the portfolio. Okay. Okay, so then we'll put, and let me see. Oh, do I have the? I don't want to go back and forth to the. Okay, so I have the risk rating here. Risk rating, A, B, C, D. It's 1, 3, 8, 6. Okay, so now in month 1, we invested in A1, which is one unit of risk. We also invest in B1. We invested in C1 plus D1. We don't know how much money we're going to put in, but the A1, B1, C1, D1 represent the actual amount of money, okay? Divided by A1 plus B1 plus C1 plus D1. This weighted average risk should not exceed 5, okay? So that's for my month 1. What about month 2? Month 2. If you can look at your model, how much money are in month 2? Which one?
Just looks from A. So
A2.
From A2? Okay, so 1, A2. Okay. Anything else? Think about it. We didn't make any investment in that month. So you probably are looking at here, right? So we didn't make any new investment except for A2. Okay, but what about the B1? Is B1 money? Is B1 still there? Is your money still in B1? Your money is still in B1. As long as your money is still in B1, it brings the risk to your total portfolio. Okay, so in that month, which ones are in your portfolio? You have A2 then. You also have B1, C1, D1, right? Those money are still in the investment. You didn't take them out yet. Okay, so that means the risk is still there. D1, okay. Then you divide that by that's equal to 5. Okay. Month 3. Okay, I'll ask you guys to write month 3 for yourself, and I'll come take a look. So think about which ones are still in your portfolio in month 3. We'll probably reinvest in A3. Is B1 still there? C1? Any questions, let me know, okay? I'm not trying to fire you. If you have questions, ask me. Try to solve it in the class. Which ones are still in your portfolio?
Yes.
Okay.
Did you write it down?
No. You set it up wrong.
Yes, right. Right,
Yeah.
right. Like the unit rate is the
Okay.
You got it? You got it?
I think I got it.
Yeah, we got
Okay,
it.
right, go back.
No.
Okay, that's month 3. Month 3
Yes.
is
So that's
probably
our,
the time
is
of
supposed to
year.
be
like our
3,
summer
yeah.
conference, like it's eating, and the way they do it, that's also false.
Yeah,
Like they
okay,
wrote it, it
okay.
wasn't just like,
And the completely,
That, it was-
the right hand side.
and they made it work.
Oh.
See, I'm just very
Less than
sad.
5.
You would never question.
Or equal to 5.
3, okay, good job. Yeah, yeah, good job. Okay, so we'll just, let me see. So month 3 we have A3 plus 3B1, B3, sorry, we're going to reinvest that month. 6-1 divided by A3, B3, C1, D1, that's equal to 5. Then month 4 we have A4, B3 is still there. This month you have C4 now, right? If you complete it. We have C4, right? Plus 6D1. And A4, B3. If you are done, you can take a look at my check for me, okay? I write. Then 5. A5, 3B. I think we're making investment in B again. 8, 4. Okay, you got the idea, right? Okay. So the next 3 minutes really important, okay? If you implement the model, everyone got the idea here, right? Okay. If you implement model like this in solver, you will for sure get an error message. Okay. Why? What algorithm do we use to solve the problem? Remember you click down linear. Okay, linear programming. Is this linear? No, okay. But can we use linear programming? Yeah, we're talking about only chapter 3, right? No, it's only like a third week. We're not going to talk about nonlinear yet. Yes, we can. You move this to this side, right? So this is a linear rising. You move the denominator to this side. Okay, so make sure. There's one homework problem later like this. Okay, make sure you move the denominator on the other side to linearize it, and then you won't receive an error message. Okay. If you got this, okay, good. We'll call it a day. Okay.